So in this video, we're going to cover putting the battery pack into the battery box and doing the fitment of the wiring. And before that, there are some things to cover with the wiring itself. So battery box, harness has been installed and threaded through, and the XT90 has been soldered inside the box. You just bring the harness in to give yourself some leeway and add the shroud, solder the connector back on, etc., etc. A separate video on this that may or may not have been published already. Either way, a link to that will be in the description, and there is likely a culminating write-up on the site, on the blog article area about this stuff, and so this is likely one component of that. Before I do any of that stuff, you'll notice that I'm wearing nitrile gloves, and it's a practice that I have. Not really a practice, it's just I wear gloves when I assemble things, especially sensitive electronics. In this particular case, this battery is wired for the Enoid X-Lite V3, and these are relatively fragile electrically and mechanically, and so there are high voltages across any number of the pins, especially on the other side. If your hands are sweaty, dirty, contaminated, etc., you could short something, bridge the pins, even get bitten by the voltage. That's happened to me before. And any energized equipment or anywhere that you're concerned about electrostatic discharge, things like that, it's a good idea to have some sort of protection on your hands, and ideally some sort of grounding setup if you're working on a particularly static prone mat. So this wood bench is not static prone, and the gloves I have work. It's these. I'll likely have a link to these either in the description or in the article that this video is a part of. And this is something also that is important. This was told to me by Battery Mooch. Sometimes they color these gloves with a carbon powder of sorts, and so it's good to take your multimeter and just check continuity on the gloves and make sure that the gloves themselves are not conductive, because that would defeat the whole purpose of wearing gloves while working on electronics. Anyway, that all being said, we're going to take a look over to the left, and we'll notice that the VESC is connected over there, as well as the Molex connector, and this wiring has been tested. This is part of the way that I test it, with the charger to the charge port, all the way to the harness through to the XT30 that goes to the BMS. And this is, as this battery requires, a setup where you have the charge port directly to the BMS, not touching any other circuit. The VESC does not touch the charge port in any way. This is a separate discharge circuit, etc., etc., etc. That's stuff that's detailed in my old original build log, which is also on the blog site. It's one of those sections where I talk about wiring in the flow glider box and the harness. So this is a similar thing to that, but I'm illustrating this just to explain sort of a way that I assemble things. When I put together a DIY one wheel or something like that, and you have two different enclosures, the front controller box and the rear battery box, I do the front controller box first. So after I've tested all the wiring and I've tested the VESC and all that stuff, and I'm confirmed that it works, which is something that I think is a good idea. It's a good idea to test everything before you bolt everything together and make sure that it's wired properly. I'll have a separate video on checking polarity. Just make sure that things work together as they should and that things are wired properly before you close it all up and then check then. So this is working, it's been tested, and what I will do is close up the front box first, assuming we're working with that flow glider box with the traditional one wheel XR type connectors, the Molexes. Assuming you're doing that, which is fairly common, I do the front box first. VESC is connected, everything is connected, sensors, button, charge port, all that stuff's done. Box gets closed up, and that is done. Then I connect the large 16-pin Molex, the power wiring, and that is connected and clicked in fully. The battery box I do last, and I'll explain why in a moment. So when you're done, or rather when I'm done putting together this sort of assembly, I end up with a front enclosure, rear enclosure assembly. Front box, rear box connected with the wiring harness or cable, and that is what goes into the frame of the board that I am building at the time. And so the final thing to go together is the battery box. So we'll take 18S2P battery, which is built for the Badger torque box, which is what this is, and it should seat right in there. And that's that. Now, I terminate the batteries in an XT90S. It's an anti-spark connector. Of course, anyone is free to request a different connector, but that's the default, and I have reasoning for that. I assume if anyone wants a different connector and they're willing to request a different connector, they're controlling their wiring in a way that they can account for the anti-spark feature elsewhere. So there's that. But by default, that's how I make battery packs, and that's the connector that I put in this box. So the reason for that is the XT90 has an anti-spark resistor in the plug. And what that does is it reduces the current rushing in to the ESC from the power source, which is the battery. So if we go over back to the VESC, the VESC has input filtering capacitors, which as a result of, it has quite a lot of capacitance. So these capacitors are empty, and when you connect the VESC or any ESC to a power source, those capacitors fill up nearly immediately. And so the current by which those fill up is limited only by the sum of resistances between the power source, which is the battery, and the wiring. There's not a lot because it's all just copper wiring. And so there's quite a lot of current, also decently high voltage from the power source. So what you get is a big spark or a pop. And so this is something that I do to manage that. Manage both the spark itself, or the pop, and also to manage the inrush current to the ESC. Generally, you want to try to avoid inrush current whenever possible, and of course you can design a circuit to do that. Or, in the case of assembling these DIY one-wheeled boards, you can just manage it mechanically by how you plug it in, connection order. And so that's why that's there. So the XT60 that most VESCs ship with doesn't have an anti-spark resistor in it. They don't make them. The smallest connector I'm aware of that has an anti-spark feature / resistor is the XT90S. Larger ones do have them. This is the smallest one, and it's a very common connector in PEVs generally. So these are fairly common. Certainly no anti-spark feature in the Molex. They're just pins, and they're fairly small, even though they can handle more or less the current that is being used. The connection, when you have that pop and that spark, is likely to damage those pins. I've seen them kind of get worn out at the tip rather. And so you end up with less contact surface of the connector, and that compromises the actual ability of the connector when that spark wears those down. And so for two reasons: one, avoiding an inrush current that may or may not cause issues at the ESC circuit level. That's the first one. And then, of course, to avoid connector wear and connector damage. XT60s can have a pop, and they'll pretty much work fine for the most part, unless it's really significant, successive reconnections, and then you're starting to wear out the tip of that barrel connector in there. XT90s, at higher voltages, the resistor doesn't last very long, especially if you're getting into 84 volt territory or 75 volt territory. But if it's once or twice, it's going to be fine, and it's going to do what you need to do. And so that's why the battery box is done last. The XT90, I do second to last if I have CAN bus, which this does for the X-Lite, at which point this will be last. The V3s do have an isolated CAN bus power supply, and so this should be able to be connected at any point. I still connect the CAN bus connector last because it sits on top and travels over the rest of the wiring anyway. And so may as well connect it last to A, be sure, and B, just because it sits on top. And so there's no reason to connect it first because it's going to sit on top of the rest of the wires. So that's all connected. The front box is connected. And now I have the battery pack seated in the box. We have this. This is the X-Lite right there. And the way I orient it in the box is like so. Balance connectors up on top, XT30s on the right, and it sits right there. Now, assuming that you've got it sitting like that, you're going to have clearance. Essentially, the lid, and this may be familiar to you, the lid has this top part where it extends upward, and that's where the top of the battery sits. And so long as the BMS and the hard stuff, like these connectors and the PCB itself and the connectors, clear the top of the battery, then the lid will seat properly. And there are a couple of things that I do to make sure that that does what it needs to do. So I've got some VHB. If you ordered a kit, it would be in there. A little piece of fish paper. And what else do I use? Kapton tape, which is a polyamide tape. I also occasionally use this. That's Tesa tape. It's a fabric harness tape. It's anti-abrasive or abrasion resistant. It's a pretty good catch-all type of material. If I'm unsure if there's going to be something pressing down on something that might abrade a wire, I'll usually just put the Tesa tape on there just for peace of mind, and precision scissors, and then that's pretty much all we need. Oh, wait, one more thing. Hot glue gun. Is that necessary? I think it is, particularly for the JST connectors. Whenever I connect stuff and it's going into a bolted together assembly, really anything, whether it's this or an E-skate, I run a thin bead of glue where the connectors meet, just to make sure that they don't unseat, because that obviously will lead to problems. Now, in this particular demonstration, I am not going to glue this because this has to get packed up and shipped, but I will demonstrate where I put the glue once I get that going. So we've got this on the underside. There are occasions where you get these and the pins are really, really tall, particularly that one right there, which I've clipped off. But if they're not standing very, very tall, then it's really not the worst thing to leave them. If they are very, very tall and you feel confident that you can clip pins without, or rather clip posts without damaging anything, feel free to do so. So there's that. VHB. So I use two pieces. I stick one right here along the bottom. And this does two things. It cushions the BMS against the box, but it also adheres it down against the box. And the other one right about there. And the top stays bare because that has to sit flat against the box. So it will sit in there, and then this will just seat right there, and that's where it's going to land. Now, where the BMS actually sits in terms of left to right is something you sort of have to just see how it goes. There's a bit of a balance. This runs over across and connects right there. The balance wires run over top and then seat right there. And so this is generally where it'll end up. It's sort of slightly right to the middle. And you just do a quick dry fit of your farthest balance connector. You have a little bit of leeway. You don't want it to be so pulled tight that those left wires kind of pull a bit more than they need to. And so I'd say right about there is fine. And then once this is all placed, these wires will fold forward, and then you'll hold them down with the Kapton tape, and that should cover it fine. Now, what I do is I take the film off of the VHB before I connect anything else, and this fish paper will sit on top right there because you are going to have some wiring traveling over the top of there. Now, you don't have to use the fish tape or the fish paper. A lot of times I will use the Tesa tape, and this can sit right there just to avoid any of the sharp stuff. And once you have stuff pressed down onto it, it'll hold itself. I also put a little bit of Tesa tape over that connector because we're not using it, and so we don't really need it. And so that just ends up being a sharp edge that we want to avoid. Make sure you're clearing the CAN bus connector. This is a pretty rough and tumble way to do it, but it will function mechanically because the goal is just to avoid, when this is clamped shut, any future vibrations causing a sharp edge of a connector to wear into a wire. And so that should do it. And again, this is unplugged. Now, just take our tweezers and un-VHB this. So here we go. Carefully. Now, once you seat this down in the battery box, you can kind of pull it up very gently just to move it over if you did not seat it in the exact spot you want. Always do this when it's not energized, so that way you don't run the risk of poking something with your metal tweezers and shorting it. All right, so that's there. Back to where we assumed we were going to put it. Right around, hold on, right around here. Good. It's right there. And you want it, now the packs that I send out have fish paper inside the wrap right there. But if you're feeling a bit extra cautious, you can just take an extra piece of fish paper, which if you're building stuff, it's a good idea to have it, and just stick it right where this all meets the battery pack. That would be a good idea. And so you want to make sure it seats all the way against the battery, and this part of the PCB clears this lip. If you didn't get it all the way in, then before the adhesive really grips, just very carefully yank it back out and try again. The clear stuff is actually pretty forgiving. That's why I've come to start using it over the, just let it unstretch. Okay, so that's ready. I'm actually gonna cut this a little bit. Yep. Just gonna trim this, and I'll explain why in a second. This is a bit too wide. So this connector ends up sitting at an angle like so against the battery pack. So I don't want to have this sit higher up than it needs to. Do you need to do all this? I don't know. This is how I do it. I'd rather just futz around with it now than possibly deal with it not closing right, or not closing as easily as it could. And so there we go. That's that. Make sure again that can connector is clear. If you have to pull this out, this clear stuff is pretty forgiving. It might stick to the box and then you just have to peel it up. And if you hold it for a second, it should de-stretch. But this is just the clear VHB. This is the 1/2 inch width. It's not very expensive. It's good to have just generally. So if you need extra, it's good to have extra. And so that is that. So we'll just go back to placing it in. Make sure it is jutted up against the battery pack, which ideally would be protected with fish paper. And then it should just angle this way and seat right there. And then if you take a look, you'll notice that it clears the top, which means that the balance connectors, once they're inserted, will sit just about flush with the top of the battery, and that'll work fine. So that's that. Next thing to go in is the actual XT60 from the battery pack, and that will go here. The ground, or rather the black wire, negative wire, faces inward. You can connect this before seating this down. Sometimes I do. Come to think of it, probably should have. It's just a bit easier, so I'll lift that edge up, plug that in. There we go. Push that back to where it goes and reseat it back down. So that's going to sit right there, and that will have a bit of play in it so it's not too tight, and will sit right there. Now, once the can connector's in, this will sit over there on top of that, and that'll be fine. The discharge connector I route also over, and it goes under there. Just sort of, there we go. I'll just leave that like that, and then that will sit there. And there you go. Then these will come around there, and we'll do that after the balance connector. So there is no real connection order, but I tend to connect the battery pack XT30 first, just out of habit. So that's what I do. Then the first balance connector, which is the larger one, that's the 13 pin, that goes in, and you'll notice the BMS lights itself up. Okay, make sure that is fully seated. Then the longer temp sensor will go in right here. Make sure that that's seated in. Then the next temp sensor will go in there. Make sure you're not pinching anything each time you do a connector. And then the final balance connector, which is the shorter one, that's a 12 pin, will seat right there. Now your BMS is connected. And so you'll notice that you have a bit of a pocket of space all here, and these will fold over betwixt the battery and the BMS because you have space here, and both the fish paper and the Tesa tape will make sure that when it's closed, the vibration won't lead to abrasion over open connectors. So some connectors are connected, hence these. Some connectors are open, and those are sharp edges, which is what we're using the fish paper and Tesa tape for. That last connector is CAN bus, so that will be connected, and then these wires will sit right there in between, which we will see in a moment. So the charge port is this, and it's not connected to anything. So we can connect this now because it is not energized. So we can just seat this in. Honestly, actually, since that is no longer, well, not no longer, since the charge port is not connected to anything, see, it's not connected, we can just go ahead and route this later. We can do the XT90 now. So the XT90, the VESC in the front is connected because, again, we did the front box, no problem. We're now doing the XT90 because that is the largest thing, and so we want to seat it. And so that now gets connected. Yeah. That's a robust connector. There we go. And then that just sits there. And there you go. And so that will do that. And you'll see that it sits right there. You got plenty of space in that channel of the box, so you're good to go. By the way, if you need more slack, you can, this is also something that you'll end up doing after you fit the lid, because that way nothing will pull on top of the corner and get squished by the lid. So once this is closed, you have a few millimeters of leeway with the actual harness, so you can just loosen the gland. And that's good to know as you're fitting this into the rails. You want to keep it the length that you need, not too much, not too little, and then you can cinch that down and you're good to go. But I leave it loose when I'm fitting stuff, so that way you have some leeway with the wire to accommodate that. So XT90 is good. We then route this around, and the XT30 goes here. This is the charge port XT30, and so that goes right there. These are all, directional, and so that goes there. Make sure you are plugging it in the proper direction, because reasons. Give ourselves a little bit of extra leeway. See? Yeah, XT90 sometimes gets stuck, so just lift it a bit. There we go. And then boom. So that's that. This is gonna sit fine. And so finally we have the CAN bus. Now what I do with the CAN bus is I lay it on top. So what I'll do first is I have this wiring that sits here, and I make sure that I can fold it down in a way that does not compromise any pressure points, or rather create pressure points. It is at this time that I will do a bead of hot glue across these connectors. So you'll see that they're seated, and there's that area where you have the lip of the connector and then the edge of the header, which is the part on the PCB. And to keep it from moving, because if you have it pushing down like this and these start to disconnect, you're gonna get all kinds of wonky stuff with your BMS, which is not ideal. And so I will take the hot glue gun and run a thin bead right along here, right on the plastic to join these two, a little bit in between the connectors. And you'll see here between the balance connectors and the temp sensors, you got a nice straight line. And so one go all the way across, thin bead. It gets a little bit in between there for some extra support. Thin bead all the way across, right there. Boom. Let it cool, let it bond properly, and once that is solid, then you'll have strain relief, because you don't want these moving around when you close the lid. So you do that, not a whole lot. You don't want a glob, but you want that nicely done so it supports the balance connectors when we close the lid. You'll save yourself a lot of trouble. This is where the Kapton tape comes in. I will use the Kapton tape to make sure that the balance wires and everything else are going to end up flush with the top surface of the battery pack. It'll still push up, but what it will do is it'll keep the wiring from going on top of the battery and getting pinched on the lid, which is not good. As long as it can keep the wiring in this gap, then the tape is successful. So we'll get about that piece. This is 1-inch Kapton tape. And so I'll just stick it on the battery area right there. Smooth that over so it adheres to the top of the battery, and I'm sure that no wires are under it on top of the battery. Then peel that back, seat the wires down and forward, and make sure that I am just keeping any of the wires from going on top of the battery pack. And they will, of course, you know, pop back up. But the point is, we don't want them on the battery pack. Now, you can also put tape here to keep the wiring from going to where the lid is going to sit. That would be a good idea. That way you're not pinching wires in the lid, because pinching wires is bad. And we don't need this piece here, because that's where the can connector is going to go. And so very carefully, we're just going to remove the excess. Or what would have been better is to just cut it a bit shorter and size it more appropriately. But that is that. And so that will clear itself. Again, we've added the hot glue across here to make sure that this is not getting pulled out when we apply the lid. And so that's that. Last, now that this is managed, is the CAN bus wiring, which will just run right on top. And you'll see that when pressure is applied, the CAN bus wiring will just sink right there. And we'll put an extra piece of tape to make sure, again, it's not sitting on top of the battery, but it'll just sink into the space because there's still quite a bit of a gap between the battery and the BMS, so the wiring will go there. Now, this is a bit, it's a bit of a trick. You got to get the CAN bus connector, turn it carefully. So this is going to go right there. And so trying to get a decent angle. So forgive me, everything is always more difficult when you're working around a camera tripod. So that has to be like so. Rather, that's probably a bit better. And then it's going to go right there. So the CAN bus connector is totally last. And so that's in. I will then use the hot glue and put a bit of a bead right there to just to secure that into that header. And then that hot glue will cool, and that is fine. Not a ton, but you do want this to just be secured into the JST header. There we go. And so now this is managed. This wiring is fine. All that's left is the cam wire, which naturally just sits here. This is when I would take one more piece of Kapton tape just to help guide that and keep it from the top of the battery. And this one, since this was the last wiring connector, we don't have to worry about having a slightly longer piece of tape, although having one that's not totally screwed up would help. Around the camera I go. Okay, so right about there. Now, if you're assembling this, you know, take your time. Okay, I'm going to salvage that piece and then I'll just cut the excess off. So you want it to sit away from the top of, let's just get rid of that and just assume that the piece we have is proper. Also, be very careful when you're using scissors around a battery and wiring. I'm used to it, but you don't just want to go clipping your wires. You got to be really, really careful. So anyone else who's doing this, probably a better idea to just cut the piece and manage that tape properly so it doesn't get all screwed up. So either way, now that that's successfully done, you see the CAN bus wiring is traveling past the lip, so it's not on top of the battery, and it's in that little channel where the extra wiring is not, and so it travels across there, and then it will sit in this channel. Now, this, depending on how you do stuff, may give you some trouble on the corner. And so one more little piece of tape right here on the corner, just to make sure that no wiring gets pinched on the top of the battery or the lid of the box. Now, if you're really judicious, you could just manually guide this when you apply the lid, or to make your life a bit easier, just run another piece of tape right there to hold all this down in place where you want it to go. On the wires, along the edge of the battery. Is that the most beautiful thing? No, but this will keep it in place where it's supposed to go, where there is free space. So that way when you apply the lid, you can be reasonably certain that you have not pinched any wires or created any pressure points or hot spots. And that, in a practical sense, is a beautiful thing, even if aesthetically the inside of this is not the most pretty setup. The idea is it works. And so, anticipating the lid pressure, we can now see that it will flatten like so. And this wiring sits here in between the CAN bus and this temp sensor on top of this unused connector. However, the Testa tape is there, and so that should do decently. You could, if you were feeling especially cautious, just add another piece of Testa tape underneath this wire or wrap this wire right here. I'll just illustrate that for you. These are the sort of things that kind of poke out to me visually when I'm putting stuff together. And again, I'll put a link to this Testa tape. I think it's excellent. You can sort of wrap the wire a little bit because you can see a couple of edges right there that might not be happy with the wire after several thousand miles. And so head it off at the pass, insulate where it's sitting. You could, if you'd like, add some fish paper on top of this if you want. I don't believe there's pressure there, and so it's unlikely that you would find abrasion. But if this board is going to be subjected to who knows what kind of riding and who knows what kind of impacts and vibration and physical abuse, then why not, right? It's an extra piece of paper, takes you no time at all, gives you a little bit extra peace of mind. This is a bit too long, so we'll just cut it. Here we go. Stick that down. And then, yeah, wedge it right on in there. Might be a little bit, there we go, underneath the 12 gauge discharge wire. It's harder when you remove the backing because now it's adhesive, but there you go. Again, not pretty, but if we're going for functionality here, that's perfectly fine. And so now that we've done that, and we've checked, we can be reasonably certain that the top plane of the battery, once the lid is seated, is not going to be compromising or pinching any wires. So at that point, you would then apply the lid and then get going. So the way I usually do the screws on the lid is I just start up the sides, which you do have to do slowly as per the instructions with the torque box. Since the threads of the screws are cutting into polycarbonate and they're cutting their own threads, it's better to do it with hand tools. And if you're using power tools, go very, very slowly because you are going to generate a lot of heat. I have experienced that kind of heat on those fasteners when you're dealing with the polycarbonate box. So that's something to be aware of. But yep, I just go slowly up the sides and then deal with the other ones. However you would like to do this. Pause. The hex nuts go on this rear lip. And so before you do any of this, I probably should have mentioned that first. Before you do any of this assembly, it is a good idea to have those pressed in here. That way, those short bolts that go into this lid in the rear lip will actually be able to catch, and then that would be much easier. So there you go. But when you're bolting this down, do be very, very careful. Check. I like to just kneel at the bench and make sure that I am seating it down properly, and then everything should compress very slightly, more or less, in the least obtrusive way. Okay, so that's the battery box. And if you have a ZBMS, obviously you would not have the CAN wire, and you would have to then accommodate however you're setting that up. But this is just a general way that I would go about it. And so I hope that was helpful.